Have you ever stopped and wondered what's really going on inside something like ChatGPT? Or how an AI can just whip up a jaw-dropping image from a few simple words? Well, it turns out, behind almost all of these incredible AI breakthroughs, there's one powerful central idea. And today, we're going to pull back the curtain on that. Because really, if you get this one concept, you basically hold the key to understanding the entire modern AI landscape. So, what is this revolutionary idea? I mean, this one architectural blueprint is the engine behind so much of what we see, from the large language models that answer our questions, to the image generators that are creating art, all the way to model-solving fundamental problems in biology, like protein folding. Seriously, it is everywhere. And it all kicked off with this bombshell of a research paper back in 2017 called Attention is All You Need. And you know what? That title wasn't hyperbole. The idea they introduced, the transformer, completely changed the game. But to really appreciate why it was such a big deal, we gotta go back and look at the problem it was built to solve. Okay, so before the transformer came along, AI models, especially for language, had a huge memory problem, a serious memory problem. They really struggled to keep track of context in long sentences, which is, let's be honest, a deal breaker if you want to understand something like a whole paragraph. So the older models, things like recurrent neural networks or RNNs, they read text kind of like we do, one word after another, in a line. This made them super slow. But more importantly, they'd often forget what was said at the beginning of a sentence by the time they got to the end. Transformers just threw that whole playbook out the window. They process every single word in a sentence at the exact same time, drawing direct lines between every word and every other word. This wasn't just a small step up, it was a total reinvention of how a machine could process information, and it made training on a massive scale finally possible. So what's the magic trick that lets them do this? Well, it's the secret sauce of the whole operation. It's a concept called self-attention. This is basically how the model figures out the importance of different words when it's looking at any single word in a sentence. To really get this, let's imagine every word has three jobs. First up is the query. Think of this as one word basically shouting out to all the other words in the sentence a question. Hey, who here is relevant to my meaning? In response to that shout, every other word holds up a sign. That sign is the key. It's like a little label advertising the kind of information it has to offer. The original word's query then zips around and compares itself to every other word's key to see who the best matches are. And here's the kicker. If there's a good match, the query doesn't grab the sign itself. It grabs what that word is really offering. And that's the value. The value is the actual substance, the real meaning that the other word brings to the table. Okay, so putting it all together, the whole process is like a four-step dance. For every single word, its query checks out every other word's key, and they get a similarity score. Then, all those scores are converted into probabilities. We call them attention weights. And finally, each word's new, super context-aware meaning is built by mixing together all the other words' values based on those weights. It's just this beautifully elegant system for building up a rich contextual understanding. So that elegant little system of queries, keys, and values, that's the beating heart of the transformer. But it's not the whole machine. It's actually just one component inside a bigger, repeatable Lego brick that we call a transformer block. And this is where it gets even smarter. The model doesn't just ask one set of questions. Nope. It uses something called multi-head attention. It's like running a bunch of these self-attention calculations all at once, in parallel. Each head gets to specialize. One might focus on grammar, another might track who's doing what to whom, another looks at the overall topic, all at the same time, weaving together this incredibly rich tapestry of meaning. And it turns out, how you arrange these blocks completely changes what the AI is good at. For example, a model like BERT, which powers a lot of Google search, uses an encoder-only setup. It can see the entire sentence at once, forwards and backwards, which makes it amazing for understanding text. On the flip side, you have a model like GPT, which is decoder-only. It uses what's called causal attention, which means it can only see the words that came before it. That very limitation is exactly why it's so good at generating text, producing a human-like response one word at a time. So for a while, everyone just thought of this as a language thing, purely for text. But then came this absolutely brilliant plot twist. Researchers figured out how to make this text-based architecture understand images. Which, of course, begs the question, how on earth do you do that? An image isn't a sequence of words, or is it? The idea, which we call the Vision Transformer, or VIT, is just ingeniously simple. You take an image and you slice it up into a grid of small patches. Then you take each of those little patches and just flatten it into a long line of data. You effectively turn each patch into a word. You then tell the model where each patch came from in the original picture, and you feed this brand new sentence of patches right into a standard transformer. It's an absolutely brilliant illustration of how flexible this architecture really is. Now, this approach is fundamentally different from the traditional way we did vision AI, using things like convolutional neural networks, or CNNs. See, CNNs have these built-in assumptions. They're hardwired to believe that nearby pixels are the most important. Vision transformers, on the other hand, have almost no baked-in assumptions. They learn all the relationships between different parts of an image completely from scratch. This makes them more of a generalist, and when you train them on truly massive datasets, they become incredibly powerful. So the transformer has given AI this incredible way to understand the big picture, the global context, in text, images, and so much more. It's an unbelievably powerful and flexible tool. But that kind of power doesn't come for free. Yeah, the very magic of the transformer, that ability to connect every single piece of data to every other piece, is also its Achilles heel. This all-to-all attention creates an absolute explosion of calculations. And as your input gets longer, the cost in both time and memory just skyrockets. So here's the crucial part. The cost grows quadratically. All that really means is if you double the length of your text or the number of image patches, you don't double the amount of computation needed. You quadruple it. This makes it extremely difficult to process really long things, like an entire book or a high-resolution video. But this field moves incredibly fast. Researchers have come up with some amazing solutions to tackle this. You have methods like sparse attention, which smartly decides that maybe not all words need to talk to all other words, and that drastically cuts down the math. Then there are things like flash attention, which is a brilliant software trick that just reorganizes the calculations to run way faster on modern GPUs. And then you've got techniques like LoRa, which let us efficiently fine-tune these massive models for new jobs without having to retrain them from the ground up. So when you zoom out, the legacy of the transformer is crystal clear. First, its design for parallel processing just blew the doors open for training at a scale nobody had even dreamed of. Second, it gave models true global context, the ability to connect the dots between the beginning of a document and the very end. And finally, it gave us a universal architecture, a single design that is now dominating not just language, but vision, biology, and so much more. It really was the one idea that changed everything. Which leaves us with a pretty fascinating final thought. We've watched this one core design master language and vision, two of our most fundamental senses. The question is, what's next? Sound? Touch? Smell? The universal nature of the transformer suggests that really anything is possible.